everyone. Now in this lesson we're going to be looking at the conversion from rectangular to polar coordinates for our vectors. And this time I've decided to choose a vector which is in the second quadrant, slightly different to last time. Last time we were in the first quadrant. So an x value for this one, let's say the x value is -5, and let's say the y value there is 12. Now, in order to calculate the value of r, we apply the Pythagorean theorem. Remember, this is a right angle triangle. So, first of all, let's go r equals the square root of x squared plus y squared -5. Don't forget to put brackets there so the square captures the negative as well. And there's no harm in putting brackets even when there's not a negative. And if I just get my calculator back wherever it is, there it is. Now I'll clear that from last time. So we want the square root of -5 squared plus 12 squared 13. So that's, you might know that one is one of the Pythagorean triples. So 3, 4, 5 triangle, a 5, 12, 13 triangle is also a nice Pythagorean triple. So that's straightforward enough. It's much more interesting when we come to do the angle. Now, the rule for angle, which you've learnt in class, I'm sure, is the inverse tan of the y-coordinate divided by the x-coordinate. So here we go. Inverse tan, the y-coordinate was 12. The x-coordinate is -5. So let's see what the calculator tells us. Inverse tan 12 on -5. Checking that I'm on degrees there, which I am. So I get -67.4 degrees. That's an interesting answer, -67.4. Now I'm going to go to my diagram for a moment and think about this, because that's a bit unexpected. Remember, we measure angles from the positive x-axis. The positive x-axis is the 0 point for angles. So that would, a line running from the origin towards the positive direction would be 0. And we turn in this anti-clockwise direction. By the time we get to the y-axis, we would have turned through 90 degrees. By the time we get to the negative direction of the x-axis, we would have turned through 180. I was expecting an answer greater than 90, but less than 180. And I get this crazy answer of -67. I wonder where -67 is. Well, if angles increase to the positive from 0 in a positive sense going this way, negative angles would turn the other way. So there would be the line for -67.4 degrees. But that's nowhere near the direction of my vector. And this is the problem with taking inverse of sine or cosine of tan. There will be two possible answers. And your calculator, in this case, it happens to have given me the answer in the fourth quadrant. But I would find a different angle in the second quadrant, which is exactly in line with this. Now, how am I going to produce the correct answer? Well, I can't just trust my calculator to know what quadrant my vector is in. I have to refer back to my diagram. And how would I go, if I was standing here, how would I get all the way to there? I would turn through a 180 degree turn, half of a rotation. In fact, I would turn in the forwards direction I would add 180. Now you'll have to think about that one for yourself by comparing the answer the calculator gives to the answer on your diagram. So I will add 180 to my answer, and I get 112.6. That's more like it. That is definitely in the second quadrant. 112.6 is my answer. The only way I would know to do that is by not just blindly accepting the answer that comes out of my calculator, but comparing my diagram with the answer the calculator gave. Now, sometimes the calculator will give you the answer in the correct quadrant and you don't need to adjust. Sometimes it won't, as happened here, and I do need to use my common sense to adjust. It will always be either add or take 180 degrees to convert. Now, lastly, I'd like to show you the automatic function on the calculator. Remember, if we hit the options key, we open up all these new menus. We move to the next screen and I select angle menu. I move to the next screen inside the angle menu and I get these lovely ones. The answers I'm seeking from this question were polar coordinates. I started with rectangulars and I want to give an answer of polar. So I hit polar and I enter -5, comma, 12. The calculator gives me the 13, which is here, the length of the vector, and it gives me the correct angle straight away, 112.6. It understands this function is a little bit more intelligent than the inverse tan function. It understands which quadrant the vector was in by looking at whether the x or the y was the positive and the negative, and automatically applying any necessary conversions. So, if the focus of your question is to convert coordinates, then I would set out with the working shown here. But if the conversion of coordinates is just a small part in a much larger vector question, I would recommend you do the automatic conversion function on the calculator if it's just a small step in a much larger question. All right, that's all for now. Thanks for watching.